All right, here we are in scenario number two. I know I could probably find a video online, but here we go. You just get to see my face. Don't want to forget that. Hey, scenario two is a situation where we have an unknown force, okay? Or maybe we're trying to figure out what force there is so we can achieve the acceleration we desire, okay? So this is a scenario where we ask ourselves, is there acceleration or is there not, okay? So again, we don't know a force, so we don't know the imbalance, so we can't find the acceleration. We have to be given the acceleration, okay? So if, right, I wanted to know, right, what force, right, this is part A, what is the force applied, right, if there is acceleration equals 0 meters per second squared, okay? So the question is there acceleration? All right. Is there acceleration? Okay. If the answer is no, right, 0 meters per second, guess what? Acceleration equals 0, so that means force net equals mass times acceleration, which is 0, which makes this whole thing 0. So force net equals 0. Again, free body diagram. I've got force applied minus force of friction equals 0. Force of friction equals 10. What's my force applied? Right? Force applied equals 10 newtons. That's the nice part, right? What if the answer is, so this was part A, where acceleration, there was no acceleration. So what about part B? If what is force applied, keep in the same case, right? If acceleration equals, I don't know, how fast do you want it to go? Let's get it to speed up fast. Let's go 5 meters per second squared. So what would that force need to be if we wanted to achieve an acceleration, right, of 5 meters per second squared? So B, yes, right? Is there acceleration? Yes, there is. So the net force, right, is going to be equal to mass times acceleration. Now, I know my mass, we still have 5, right, kilograms. And I know my acceleration I want, right, is 5 meters per second squared. And my force net, this still comes from the free body diagram, is force applied minus force of friction. And honestly, I'm just going to leave that there. I should have plugged this stuff in, but I already did. So I can do this. This is 25 force applied minus 10, right, newtons. Okay. So how do I solve for the unknown, right? I add 10 to both sides. It just becomes, once you've got the equation, it just becomes algebra. And we know how much we love algebra. Force applied would need to be 35 newtons to achieve 5 meters per second squared. So to get this, we're always working with this foundation. This is going to be our primary equation for this chapter or unit. And it was the last one. We just had it always equal to 0. The first scenario, if I don't know what a force is, I ask, is there acceleration? If the answer is no, we go over to this section where the net force equals 0. So these forces will be balanced, right? Balanced, unbalanced is back again. So we can set it up and do all this long work if we want. I know most people won't want to do that, but I just want you to see how the equation works to get used to it so that we can get on to this stuff, right? If there is no acceleration, then these are balanced. I can answer this simple question. Rightward force is equals to leftward force. Force equals 10. So this is kind of the long way to do it. Okay? Now, if there is acceleration, is there acceleration? Yes. Boom. Right? Then I do have a net force. Okay, I just don't know what that one is. So it's just an unknown or a variable, which we love from algebra. We always love setting up equations with our word problems. I know my force of friction, I know my mass, and I was given my acceleration. I just plug it in. This side, it's basically given information. Okay, so force applied minus our force of friction equals 25. I want to solve for force applied. Now this is just algebra. I add 10 to both sides. Force applied needs to be 35 newtons to achieve 5 meters per second squared. So I'm hoping you're not just writing down the problems, but you're adding questions. Is there acceleration? Are the forces balanced? Are the forces unbalanced? Right? And then we're learning how to use this setup when we get into a little more complex problems. So we need to do this in the simpler. Everything's horizontal, everything's or vertical and horizontal. We need to get used to using this equation so we can tackle things that are a little more complex. All right, you can screenshot that or whatever you need to take notes. Again, the notes can be on all one page. Take a picture, post it or submit it. Make sure it's good so I can see it. But submit it for your assignment to show that it's complete. All right, see you later.